Welcome back to Statistic 1, Chapter 3, Probability, topic Independent and Dependent Events. So first we'll work with the independent event first. The two events are said to be independent when the outcome of the first event does not affect the outcome of the second event. So for this one, the probability of event A intersect with event B will equal to probability of event A multiplied by probability of the event B. So let's take an example to see whether they are two independent events. John joined two cooking competition, and the probability that John will win the competition A is 0/3, and the probability that John will win the competition B is 0.6. So these two competitions are separate, and then whether if John will win the competition A cannot ensure that he will win or lose the competition B. So the outcome of the first competition does not affect the outcome of the second competition. So they are independent events. So now we will find the probability that he will win the both competition, and the second one that he will win or one has one win and one lose. So now we will draw a tree diagram to represent all the information we have. For here, competition A that win or lose. So for competition A, the probability that John will win is 0.3. But wins or lose add up to 1, so this one is 0.7. So the next competition is competition B, and we have that the competition B in here. Competition B, win or lose, win or lose. The probability that John will win the competition B 0.6, and the probability that he will lose 0.4. The same for here, 0.4. Now they ask us that the probability that he win the both competition. You see here, he win the first competition A, which will be in here. Win the second competition B in here. So P of win both equal to 0.3 multiplied 0.6 equal to 0.18. So here, now we look at the question that he has one win and one lose. So he can win competition A and lose competition B, or he can lose competition A and win competition B. So we have two cases in here, one win, one lose, equal to that he will win competition A and lose competition B will be 0.3 multiplied 0.4 plus the probability that he will lose competition A and win competition competition B 0.7 multiply 0.6 equal to 0.12 plus 0.42 equal to 0.54. So that's how we can use this method to find the probability of independent events. Conditional probabilities. Conditional probability is used when your estimate of the probability of an event is altered by your knowledge of whether some other event has occurred. So now we would divide them into situations that whether event A and B are independent or event A and B are dependent. Now we have the general form of the conditional probabilities, that probabilities of B given A equal to probability of both A and B occurs over probability of A. Here, for independent event A and B are independent. So whether event A occurs or not, event B is not affected. So for this case, so probabilities of B given A is equal to B, probability of B, because whether A occurs or not, B is not affected by A. So P of B equal to P of B intersect with A over PA. So we will have P of B intersect with A equal to PA multiplied by PB. So for independent event, dependent event, I will choose another color. Dependent event. So for dependent event A and B are related to each other. So whether A occurs or not, it will affect the probabilities of event A event B. So P of B given A, that event A has occurred, and probabilities of B is here is now affected. In the same, we cannot change this one because they are dependent. So equal to P over B intersect with A over P of A. Then P of B intersect with A equal to PA multiplied by P of B given A. So when we have the data, we want to know which one is, well, which of two events are independent or dependent. We will use this formula to find whether they are dependent or independent. If we can prove that P of B intersect with A equal to PA multiplied by PB. So these two events are independent. This one, if P of B intersect with A different from PA multiplied by PB, so it will be dependent. Now we are going to work on this question to understand more about conditional probabilities, dependent and independent events. Maya is going to take the final exam. The probability that Maya will study for the exam is 0.75. If she study, the probability that she will pass the exam is 0.8. But if she doesn't study, the probability that she will pass the exam is 0.3. The first question is that find the probability that Maya will pass the exam. So first of all, we would construct a tree diagram. The first one, study. Second one, no study. It will be pass or not pass. Pass or not pass. From the information below, we can see that the probability that Maya will study for exam is 0.75. 75 here, because these two add up to 1, so probability that she will not study 0.25. And if she study, the probability that she will pass the exam is 0.8. If she study, the probability that she will not pass the exam is 0.2. Because these two add up to 1. And here is 0.3. and here 0.7. Find the probability that Maya will pass exam. So if she studies, she will pass exam in this way, and if she doesn't study, then she will also pass exam in this way. So we have to find the sum of these two ways to find the total probability that she will pass exam. Probability of pass equal to P of study pass plus P of not study and pass equal to 0.75 multiplied by 0.8 plus 0.25 multiplied by 0.3, and we have 0.6 plus 0.075 equal to 0.675. Moving to the next question, given that Maya doesn't pass exam, find the probability that she didn't study. Here, so we have P of she didn't study would be no study, given that she didn't pass, equal to P of she not study and not pass exam, not study, not pass, over P of not pass the exam, because the probability that she will pass the exam will be 0.675, so probability that she will not pass the exam equal to 1 minus 0.675 equal to 0.325, and the probability that she will not pass and not study the exam would be this one, not study and no pass be this one. So we have here 0.25 multiplied by 0.7 over 0.325 equal to 0.535.